Welcome to lesson 7.5. This is on solving special types of linear systems. In previous videos, we've talked about the three different methods on how to solve a linear system: by graphing, using the substitution method, or by using the elimination method. In this video, we are going to explore different special types of linear systems. So let's get right to it. So right away, we can do this by looking at the number of solutions in a system by looking at the slope and the y-intercepts of the line. In order to do this, I do need to put my answer in slope-intercept form. Okay, so once you have put your two equations into slope-intercept form, there are a couple things we can find out. We can figure out the number of solutions by just looking at that. So if you have one solution, then they have different slopes, and they could also have different y-intercepts. They're completely different lines. If there's no solution, that actually means that they have the same slope and that they have different y-intercepts. This means that the lines are usually, or they're always, parallel because they will not cross over each other. All right. And then infinitely many solutions, they have the same slope and the same y-intercept. Basically, they are the same line. Okay. There are specific vocabulary words that go along with having no solution, okay, and with infinitely many solutions. So if you have no solution, this is actually called an inconsistent system. They don't cross, it's inconsistent, it does not, there's no solution, okay? If you have infinitely many solutions, it's called a consistent dependent system. All right, so be familiar with these terms. They're not widely used in word problems or anything, but I do want you to be aware of what I'm talking about if I ever say an inconsistent system or a consistent dependent system. All right, so let's look at some examples of what these special types of systems would look like. So the first one, it says show that the linear system has no solution. All right, so I have these two equations. I have 3x plus 2y equals 10, and I have 3x plus 2y equals 2. Right away, I want to put each of these equations into y equals mx plus b, or y-intercept, slope-intercept form. So I'm going to solve for y here. So I am going to um, get y by itself, and I'm going to subtract 3x to this side. So I'm going to end up with what? 2y equals 10 minus 3x. And I'm going to divide by 2 and divide everything by 2. And then my solution would be y equals 5 would be my intercept minus 3 over 2y. Okay, so that would be my first line. My second line, same thing. I'm going to subtract 3x over here. So I'm going to end up with 2y equals 2 minus 3x. Divide again by 2, by 2, by 2. So right away you should notice once I have y equals 1 minus 3 over 2y that my slopes are the same. Because my slopes are the same, it means automatically that my systems are going to be parallel, meaning that they are not going to have a solution. So if I were to graph these, I would graph my intercept. So this is this line is this guy, and I just realized I wrote y, not x, on these. Sorry about that. So that goes there, and then this guy is this line right here. So you would graph your intercept at 5, go down 3 over 2 here. Intercept is 1. I could go down 3 over 2, or in this case, we could go up 3 over 2. My lines would be parallel. All right, another method on how to solve these is actually using the elimination method. If you were to line these up right away the way that they are, you know right away, if I were to subtract these, 3x minus 3x is 0, 2y minus 2y is 0, 10 minus 2 is 8. This is not a true statement. 0 cannot equal 8, obviously. So because of that, there is no solution to this problem. Okay? All right. Now, if we want to show that they have infinitely many solutions, meaning that the lines are exactly the same, I'm going to graph them first, okay? So right away in this one, I know my intercept and my slope because it's already in y equals mx plus b form. Okay, but this guy I need to put in that form, so I'm just going to do that real quick. I'm going to subtract x over to this side, so I'm going to end up with negative 2y equals negative 4 minus x divide by 2, or negative 2. So my new equation is going to be y equals 2, because negative 4 divided by negative 2 is a positive 2. And then negative x divided by negative 2 is actually going to be positive 1 over 2x. Okay, right away you should notice they are the same line. So I'm going to graph them. I notice that they're exactly the same line. Okay, and that shows me that there are infinitely many solutions. A second method, using the substitution method to find out if there's infinitely many solutions, we can just plug the equations into each other. So in this case, y already equals 1 half x plus 2, so I'm going to plug that into my first equation, which they do down here. So I end up with x minus 2 times 1 half x plus 2 equals negative 4. Solve it out. And then this would become 2 times 1 half x would be 1x. X minus x is 0x. So I end up with the solution of negative 4 equals negative 4. Since that is a correct statement, but there's no x's left, it means that there's infinitely many solutions since this is a true statement. Okay? All right. One last example. I'm going to actually give this to you. I would like you to solve these linear systems and tell whether the linear system has one solution, no solution, or infinitely many solutions. So actually I want you to pause, try and do these on your own. I am going to put the solution up here, but I do want you to try and do them by yourself. So pause, do your thing, and then you can restart. All right, so for the first one, for A, 5x plus y equals negative 2 and negative 10x minus 2y equals 4. I'm going to put them into slope-intercept form, and I'm going to see that they are the same line. And so they have infinitely many solutions. With the second one, same thing. I'm going to put them in y equals mx plus b form. And they have the same slope, but different y-intercepts, which means that they have no solution. They are going to be parallel lines. All right, so just a quick overview of what this would look like. We have 3 different special types of systems. We have the one solution, which is what we've been mostly working with so far in this chapter. Then we have the no solution, which means the lines are parallel and they have the same slopes but different y-intercepts. And then we have infinitely many solutions, means that the lines are the same and they have the same slope, same y-intercept. Okay. So please understand the difference between all 3 of these, and otherwise that's all I have. Come to class with any questions.